You ever just stop and think about it? You hit play on your phone, and poof, music, a podcast, whatever. It just shows up in your ears. There are no wires connecting them. It really feels like straight up magic. But of course, it's not. It's actually this incredible feat of engineering. So let's pull back the curtain and see how it all works.
Yeah, that's really the big question, right? How does your favorite song make that seemingly impossible jump from your phone, through thin air, and into your headphones? What are these invisible strings pulling it all together? We're going to follow the entire journey of a sound, right from the digital file all the way into your ear.
All right, so the journey actually starts inside your phone, not in the air. The very first thing that has to happen is a translation. See, a song is, at its core, a physical sound wave. And that wave has to be turned into a language computers get. And what's that language? Well, it's numbers.
This whole translation process, it's called digitization. And you can kind of think of it like this. Imagine you're taking thousands and thousands of super fast snapshots of the sound wave every single second. Each snapshot measures a specific point on the wave, and all those measurements create this incredibly detailed map, but it's a map made entirely of numbers.
And when I say lightning fast, I am not kidding. To capture everything we can possibly hear, engineers are taking, get this, 44,100 of these snapshots or samples every single second of a song. That is just a staggering amount of information for just 1 second of music.
But wait, it gets even more detailed. For each one of those 44,100 samples per second, it's assigned a value from over 65,000 possible audio levels. That's what we call 16-bit depth. It's what gives digital audio that incredible richness and accuracy. It's just so much data.
Okay, so now we've got this perfect, super detailed digital map of the song. But there's a big problem. It's huge. A typical 3-minute song, uncompressed, can be like 30 megabytes. If you tried to send that wirelessly in real time, oh, it would be a stuttering, buffering disaster. So that file has to go on a serious diet.
And this is where something called an audio codec comes into play. A codec, which is just short for coder-decoder, is basically this really smart piece of software. You can think of it like a digital vacuum packer for data. Its whole job is to shrink that giant list of numbers down to a size that's actually small enough to travel through the air.
And the difference it makes is just night and day. The codec is smart. It gets rid of the data that our ears probably won't even notice is gone. This makes the file way, way smaller, but you barely hear a difference in the quality. And that is the secret sauce that makes smooth, nonstop wireless streaming a reality.
All right, so our data is now nice and small, ready for its big trip. It's time for the leap through the air. This is where Bluetooth comes in. It's the technology that takes our little package of code and turns it into an invisible radio signal.
And the speed we're talking about here is just, it's mind-boggling. Your phone's little Bluetooth transmitter is sending out about 1 million ones and zeros every second. 1 million. It encodes those digits onto radio waves that can just pass right through walls and other stuff to get to your earbuds. So how is it actually sending all those ones and zeros? Well, it uses a really cool technique called frequency shift keying. The easiest way to think about it is like a super fast traffic light for radio waves. It just switches back and forth between 2 slightly different frequencies. One frequency means 1 and the other one means 0. Your earbuds just watch for those super fast changes and read the message.
Okay, but think about this for a second. The air around us is super crowded, right? You've got Wi-Fi, microwaves, other people's phones, all using similar radio space. So how on earth does your music cut through all that noise without turning into a jumbled mess? Well, it takes a really clever and really fast secret handshake. To get through all that traffic, Bluetooth doesn't just stay in one lane. Nope. It has 79 different channels it can use. Think of it like a giant 79-lane highway. That gives it plenty of room to find an open road.
And this is where it gets absolutely wild. To make sure it never gets stuck in a traffic jam, the signal doesn't just pick a lane and stay there. It hops. It jumps between those 79 channels 1,600 times every second. The technique is called frequency hopping, and it's what makes the connection so strong and almost impossible to mess with.
So how does all this data stay organized while it's jumping around so fast? It travels in these neat little bundles called packets. The best way to picture it is like a digital envelope. Each envelope has an access code on it. That's the address, making sure only your earbuds can open it. Then there's a header with some instructions, and finally, the good stuff, the payload, which is that little chunk of your music.
Okay, we're on the home stretch now. Those packets have done their crazy dance, hopping 1,600 times a second, and they've made it safely to your earbuds. Now it's time for the grand finale, turning that stream of ones and zeros back into actual sound.
So inside your earbud, the whole thing basically happens in reverse. First, it receives and checks the packets. Then, that audio codec gets back to work, but this time it decompresses the file, puffing it back up to its original size. After that, a little chip turns that list of numbers back into an electrical wave, and that electrical signal makes a tiny speaker vibrate, creating the pressure waves that your eardrum understands. And boom, you hear your music.
So really, the next time you put in your earbuds and press play, just think about that for a second. This whole silent, invisible symphony of engineering that's happening, from turning sound into numbers, to shrinking it down, to hopping it across the air thousands of times a second, millions and millions of calculations are happening, literally in the blink of an eye, all just for you.
It's pretty amazing. And it kind of makes you wonder, doesn't it? We've completely cut the cord on audio. So what other invisible strings are engineers working on right